Well, yeah, thanks everybody coming out. I'm Alex, the owner of Garden Grove Organics, and just wanted to do this as our first class. We're planning on doing hopefully about one a month is my idea, and hopefully not just me. I'm going to get some different nutrient vendors and hopefully some of the other people that work here and try to get people from the community so it's not just the knowledge that I have because I'm going to exhaust that probably mostly tonight. But this is, I'm calling it Anatomy of a Grow Room, but essentially it's just the equipment and supplies to build a basic grow and some of the most common questions that we get. So without further ado, this is going to work. So main topics that we're going to cover is lighting. That's about my favorite. Nutrients, which we carry a ton of, get a ton of questions about. Grow media, and then environment, which is one of the most important things. So lighting, before I go on to that, lighting, if you don't know as far as, well, I'll just start by saying when you're moving indoors from an outdoor type setting, you're trying to replicate nature, and that's a difficult thing to do. It's not just a matter of tossing seeds out and throwing some fertilizer and just kind of hoping that it works. When you're moving inside, there's a lot more to think about, and the biggest consideration is lighting because you're trying to replace the sun, and the sun is a hard thing to replace. So the light is always the key to your garden. You can all the other things. If you get them a little bit wrong, if your lighting is right, you're going to have better results than if you have bad lighting and good nutrients. There's no amount of nutrients or proper grow media or proper pH control that can replace good lighting. So main types of lighting that you're going to see these days, there's all different types, but HID or high intensity discharge, that's all your high pressure sodium, ceramic metal halide, anything that's got a big bright bulb that looks like something you'd see in a parking lot is going to be considered an HID light. Fluorescent these aren't fluorescent, these are actually LED, but typical office lighting, shop lighting, and it's still pretty common, especially for vegetative growth. And then LEDs. This is an HLG LED. So my favorite by far is LED, and we'll get to exactly why. First thing that most people think about when they think about just regular lighting versus plant lighting is spectrum. Real quick on spectrum, the visible light is really just this tiny, tiny section of electromagnetic energy. Infrared is, that's essentially heat that you feel on your skin from sunlight. It's radio waves, all the low frequency stuff. Ultraviolet is what actually gives you a sunburn. It's X-rays, gamma rays, all the crazy cosmic stuff. And the part that we can see and that plants use is this tiny, tiny little section here that goes from 400 nanometers to 700 nanometers. That is the range that is visible to us. Some people can see a little bit further into the ultraviolet range, but generally that's considered the human vision range. And coincidentally, that's also what helps plants grow. Now, ultraviolet and infrared do things for plants, but really what actually generates photosynthesis and makes plants grow is this visible light spectrum. This is the McCree curve. Keith McCree was a scientist at Texas A&M. He was a physicist, actually, and he was trying to find out exactly, at this point in 1972, nobody really knew how plants used light or what part of light plants used or how they used it. They knew plants used light, obviously, but they didn't know much more than that. So Keith McCree did a whole bunch of different experiments to figure out exactly how plants use light. And his experiments, by today's standards, would still be considered a little bit flawed. It's not perfect by any means, but it's still a pretty good representation of what plants use. He did a whole bunch of, essentially he put some leaf segments of plants and in a machine that shined different monochromatic colors of light. So one specific wavelength of light, and then he measured the amount of CO2 that leaf segment absorbed, which is going to tell you how much it's plant respiration, so that's going to tell you how much they're using that wavelength of light. So if you look, this is what sunlight produces. So he got it probably pretty good. There's a good chance that plants are very adaptable. They're going to use most of what the sun is giving them. So yeah, he did a pretty good job, and this is still what we use today for the most part to figure out what plants use. Now, a lot of people, there's a myth that plants don't see green light or don't use green light because the common logic is, well, plants are green. We see that green light reflected because the plants don't use it. But really, there's just this tiny dip in the blue-green area. It's not even centered on green. It's kind of this blue area here, but it's just a little bit less. Really, the main reason that we see plants as green is because our eyes are most sensitive to green. Our eyesight really, in comparison to how a plant uses light, our eyes are pretty terrible. We really see mostly green. So this is the spectrum of a typical high-pressure sodium bulb. And as you can see there, it's mostly yellow and orange, not a whole lot of blues, not a whole lot of deep red or anything. So it's very limited. T5 fluorescent is big spike of green right there, little bit of red, little bit of blue. That is the reason it makes great office lighting and work lights, because our eyes are sensitive to green. Fluorescents put off that nice greenish spectrum, even though we see it as white light. That's why pictures that you take under fluorescent lights always look pretty bad. They always have that kind of green hue. And this is a modern LED. This is actually a Gavita 900E. Now, LED grow lights can come in all different types of spectrums, but this is a pretty common one, especially for what you'll see in this industry. And if you look, this compared to sunlight or the McCree curve is way closer than these other two. So that's your first sign there that LEDs, spectrum-wise, crushes anything else. And they can be configured. Certain LEDs can be dialed in to different frequencies of spectrum depending on what they're being used for. The one thing I do want to touch on, this little bump of red here that you see, all the rest of this is just from the white LEDs. So like the lights we've got in here are considered white light LED. It's really a blue diode with a phosphor coating that gives you all these other colors. The red, it's not supposed to do that. The red is just a little diode they add. So a lot of grow lights you'll see have some added red. It's more a marketing thing than anything. It gives you a tiny bit of efficiency boost, but plants don't really need that extra bump of red. So this are the grow lights you'll see. If you go on Amazon and just search grow light, you'll probably find something like this for a couple $100. And this is the spectrum they're giving you. 5-10 years ago, that was almost everything that was on the market were these what we call blurple lights. And what they thought they could do with these is use a red diode and a blue diode to target the peaks. But if you've ever grown with anything like that, you're going to see that the results are pretty terrible. Unless you're growing lettuce or something that's really small, any kind of larger plants, they really want that full spectrum of light. Otherwise, you get some really odd results. So we just say no to what we call blurple lights. Intensity is really the name of the game. Spectrum matters a lot, but it's all about really intensity. If you want to grow big plants, big buds, big yields, you got to have a lot of light intensity. Think about the sun. The sun is going to blind you if you look at it. If your grow light isn't basically blinding you when you're looking at it, it's probably not bright enough. People used to measure that in lumens. Lumens are a measurement that it's relative to human vision. So if you're measuring a light with the same spectrum against another light with the same spectrum, lumens will give you a little bit of an idea. It'll at least tell you which one's brighter than the other, but it's not the best tool. Some people are still measuring the value of their light in electrical power. They're saying, oh, it's a 1,000 watt, or it's a 600 watt, or it's equivalent. You'll go on Amazon, you see these lights that say it's equivalent to 2,500 watts or whatever. But that's garbage. Especially with LEDs, the amount of power the light uses isn't really telling you what it's putting out. What you really want to be measuring is PAR, which stands for photosynthetic active radiation. And that is that light in that last slide I showed you with the spectrum. PAR measures how light is generated relative to how plants actually use it. And it's not a matter of The perceived intensity, it's actually a matter of photon count. So without getting into any of the physics of that, don't use a lux meter or a kilowatt. You can use a kilowatt just to see how much power your light's using. But what you really want to use is a par meter. And when you're looking for a grow light, you want to look at these numbers, especially the micromoles per joule. I'll get into what that means in a later class. But essentially, that's your efficiency. That's like your miles per gallon on a car. And we get to efficiency. So HID light, the best ones out there are going to be about 1.7 micromole per joule. It's going to, on the box, it's going to tell you that it's a little bit more than that because they're measuring the lamp by itself. But once you get it in a fixture with the reflector and everything, there's a little bit of a loss there. So 1.7 is really about as good as it gets, maybe 1.8. Fluorescents are terrible, 1.2. LEDs, the LEDs we carry, most of them are about 2.6, so almost double what you're getting from an HID light. And actually, they go way beyond that, too. There are commercial lights out there with 3.2 now. They're going to be specific spectrums for growing lettuce and stuff like that. But yeah, 2.6, way better than all this. So not only are you getting a better spectrum, but way more efficient light from an LED. So that moves us on to plant nutrients. Any questions on lighting? All right. So that moves us on to nutrients. When you think of nutrients for a plant, you think fertilizer, but you've also got some things that aren't fertilizers, supplements, additives. These are some of the most common brands. These are Gaia Green, Down to Earth are a couple of fully organic lines. General Hydroponics, that's the classic. That's one of the first that came out back in the 70s. Fox Farm, really popular for especially beginners. And then one of my favorites, Advanced Nutrients. They kind of make everything that you can think of that'll benefit a plant. So why do plants need nutrients? We've got half the store down there is full of bottles of nutrients. So why do plants actually need all this stuff? You know, you go to the park and you see all these trees and everything growing. They're not using any kind of bottled nutrients. So we kind of break down exactly what a plant does, like a plant's job, how it generates biomass. So in simple terms, this thing in the middle here is a chloroplast. That is the cellular body in a plant that is responsible for photosynthesis. So what a chloroplast does is it takes CO2 from the air, combines that with water, and it uses sunlight to actually break those molecular bonds apart to create carbohydrates, mostly in the form of fructose and glucose. And if you look close here, it might be a little bit small for you, but if you look at the fructose and glucose, it's really carbon, oxygen, and hydrogen. That is all these are made of. And if you look at all the wonderful compounds that plants make, terpenes, and all your medicinally active stuff, it's really all those same three atoms: carbon, hydrogen, oxygen. And if you look up here, the plants can get that from their environment. They get the carbon from CO2, they get the hydrogen from water, and they get oxygen from both. And they actually, they get a lot of oxygen from those compounds, so they end up giving a lot of oxygen off as a waste product, and that's how we're all here and can breathe. So that kind of begs the question, again, why do plants need nutrients? If you look at a nutrient bottle, it's NPK, or the three numbers you'll see: nitrogen, phosphorus, and potassium. But you don't see that in any of these compounds they produce. First one is nitrogen. It's the most important. It's the first element that scientists knew that plants needed. And that's because nitrogen is an integral part of chlorophyll. Plants have to have nitrogen to make chlorophyll. When your plant is nitrogen deficient, it'll fade out. You'll lose all that green color because they're moving the nitrogen from the old growth up to the new growth to try to create more chlorophyll, because chlorophyll is that's money for the plant. Phosphorus is the second most important. That's responsible for ATP, which is it's the energy that plants use. This is every element that a plant uses, and there are different uses. I'm not going to go through all these, but if you look, nitrogen, obviously carbon, oxygen, hydrogen, we already talked about that. Nitrogen, phosphorus, potassium. Nitrogen, again, is going to be chlorophyll primarily, amino acids, cell formation. Phosphorus, again, cell formation, protein synthesis, fat and carbohydrate metabolism. Potassium is big for water regulation. Calcium and magnesium are they're considered secondary nutrients. They're also super, super important, especially calcium. And then all these other micronutrients, the plant really only uses in trace amounts, mostly for making enzymes that is for different signaling within the plants. But the plant has to have all these different elements to survive. So even though they're only using it in tiny, tiny amounts, they're crucial. So in nature, this is organic nutrient cycling. In nature, when you're not feeding them liquid nutrients, plants rely on microbes. You can see all that green stuff in there. Plants are on their own are really, really bad at pulling the mineral nutrients from soil. They're spoiled at this point because they've co-evolved with bacteria and fungi in the soil that help them do that. And the way this works, plants create sugars like we talked about a couple slides ago. They combine the carbon dioxide and water. They create these sugars, and it's actually a trade system. They push those sugars out through their root zone, give them to the bacteria. They attract the bacteria and fungi. They trade the sugars for the minerals. And where do these soil microbes get the minerals? They get it from organic stuff like dead fish or rocks. And nitrogen-fixing bacteria actually pull nitrogen out of the atmosphere and put it into the soil. So that's when you talk about crop rotation, like farmers moving their crops around into different fields, and they'll have legumes or like peas or something that attracts these nitrogen-fixing bacteria. That's the reason they're doing it, because plants deplete the soil of nitrogen, and you want to get that back in. So this is, if you're using organic fertilizers or like for your outdoor garden, this is how it works. Plants cannot take up any of this stuff. If you're feeding them fish meal or bone meal or compost, plants actually don't eat organic whatsoever. Plants don't eat anything organic. Plants create organic stuff. They take in inorganic ions, essentially, and then they create organic compounds like sugars. So the microbes are what is responsible for turning these organic products into the ions that attach to the root zone, and plants can take them up. So in hydroponics, which is actually most of what we do, even if you're using a soil like a Fox Farm or something like that, if you're buying a soil here and then feeding it liquid nutrients, you're doing hydroponics, even if you're feeding it by hand. So in hydroponics, we skip the whole organic thing, and we just give them the ionic compounds that they need. Calcium nitrate's one of the top ones, magnesium sulfate, potassium nitrate, monopotassium phosphate, manganese sulfate, ammonium molybdate. These are all generally, they're mined minerals. Sometimes they have to do a little bit of acid treatment or something else, but typically all the stuff that you're feeding to a hydroponic system, it's not synthetic. People like to use the term synthetic, but it's not what you think of synthetic, where some guys in lab coats are mixing chemicals. It really, most of the time, it's a mined mineral, and they might have to acid wash it to purify it or something like that. But when we talk about hydroponic nutrients, people love to say synthetic, but it's not synthetic like you think of. It's not, based on petroleum or anything like that. They're mined minerals. With the hydroponics, pH is incredibly important. In organics, it's less important. The soil, the microbes take care of a lot of that stuff for you. It's still important, but in hydroponics, it's incredibly important for your pH to be correct so that all these different nutrients can get taken up. Base nutrients, that's the main thing. That's all those elements that we talked about a few slides ago. Your base nutrients are what's going to do that. So whenever you're starting, when people come in and say, I've never done this before, what do I feed my plants? Before we get into all the crazy bottles and supplements that you can use, base nutrients is what you start out with. That's essentially, if you're putting it in terms of like a bodybuilder, that's your food. You can go to GNC and buy all kinds of different protein powders and creatine and all the different vitamins and everything. But the most important thing for a human is food. The most important thing for a plant are the macro and micronutrients. So 1 part nutrients are really common. That's normally what we start people out on just because it's easy. If 1 part nutrients were the best, then that would be all we sell because it's got really everything the plant needs in it. You see this one, Tiger Bloom, to 284, which is a pretty basic bloom formula. Plants in bloom phase don't use quite as much nitrogen because they've already taken up a lot of nitrogen in the vegetative phase for creating all that leafy matter, and they're using a lot more phosphorus for creating fruits and flowers. But 1 part, really, it's usually pH stability isn't the best. It might take a lot to mix it into your nutrient solution. Sometimes some different things will fall out of solution. So there are also 2-part systems. And 2-part is a little bit deceiving because it's really 2-part for veg, 2-part for bloom. And the reason they do that is because all that stuff, all those ions in that form, in a concentrated liquid form like that, don't always play well together, especially calcium and phosphorus. So they separate out the calcium and phosphorus, separate out a few things that don't play well. So with the 2-part, you're going to mix the part A into your solution, mix that really well, put the part B in, mix that in really well. I like a 2-part. 3-part is classic general hydroponics. Again, they kind of started this. 3-part is really versatile because it's 3 parts all the way through, from veg to bloom, and you vary how much you use each of those 3 parts. So you can see in the micro here, it has no phosphorus. The bloom has no nitrogen, but when you use their nutrient chart and combine them in the right amounts, they're going to give you everything you need. But again, base nutrients, if you use no other bottles, you got to use base nutrients. That's what's going to make your plant grow. I'm going to go through a few different supplements and additives. So microbes, as we talked about in outdoor and soil, is super important, but they're also important in a hydroponic garden. Beneficial bacteria is the main thing. The biggest thing that it does is it promotes nitrogen uptake. It also is going to help protect the root zone against harmful fungi. It creates some of those enzymes that the plants use for signaling, keeps the root zone clean. So I always use some sort of beneficial bacteria in anything, hydroponic, soil, whether, lettuce, fruits, flowers, anything, I'm going to be using some sort of beneficial bacteria. In flowering, beneficial fungi is very important. Mycorrhiza, as it's also known, promotes nutrient uptake, increases drought resistance, improves the soil structure. That's a huge thing. Mycorrhiza creates these networks in the soil that, it helps the water to get absorbed instead of just running off or running straight through the soil. So mycorrhiza is very important. You can see with bacteria or mycorrhiza, you can go online and look for side-by-sides of just a garden that just uses fertilizer versus a garden that adds some sort of microbe, and it's just a huge difference. They have all kinds of benefits, and really scientists are just barely scratching the surface of what beneficial microbes can do with plants. And plants have evolved with these microbes, so they really rely on them in nature. There's all kinds of other ones. Great White is a blend. It's got all kinds of bacteria and mycorrhiza in it. That's one of our favorites, very cost effective. Mammoth P is one of the ones that is becoming more popular. It's a special phosphorus fixing bacteria, which is kind of rare. It was developed, I think, at University of Boulder, I want to say. But that's super popular, specialized microbe. Voodoo Juice from Advanced Nutrients. It is a bacteria called Bacillus amyloliquefaciens, I believe, and it's a special bacteria that chains together, and not only is it going to give you huge roots, but it's going to protect against fungal disease, root rot, that kind of thing, especially if you're in a soil type medium, you're going to be a little more susceptible to root rot. So something like Voodoo Juice is going to really help out with that. All right, next up, kelp, or seaweed, as it's more commonly known. This is one of my absolute favorites that, again, I use it just about every time, unless I'm doing like some hydroponic lettuce or something where I want the system to be really clean. Kelp is just one of the best organics out there, and you can use it in hydroponics also. The main benefit of kelp is the plant hormones. Kelp is the fastest growing plant in the world, can grow feet in a day. So the whole plant is just full of growth hormones, essentially. And there's some nasty synthetic hormones that you don't want to use. not on anything that you're going to ingest at all anyway, but kelp is a great source of natural plant hormones. Also, it's got food for the beneficial microbes, and it contains over 70 micronutrient forms. This is the psycho-rhizofuel. That's one of my favorites that we've got. But again, if you want to go beyond base nutrients, definitely do microbes and then kelp. If you don't do anything else, I would recommend those. Silica is another big one. Plants take up silica. It's essentially silicon, glass, really, that plants take up and they build into their cell walls. So you'll see this is a plant that hasn't been treated with silica, and this is a plant that has been treated with silica, and it adds that silica into its cell walls, makes the cell walls a lot thicker, better structure. Strengthens cell walls, guards against environmental stress and drought, helps them keep that moisture within their cells instead of losing it, improves the uptake of water and minerals, and it helps protect against insects and fungal pathogens. Insects have a lot harder time, especially your really small insects like broad mites, cyclamen mite, that kind of thing. They've got a little bit harder time piercing those cells and sucking the stuff out of it when you've got silica. There are two forms of silica. Well, there's more than two forms, but two common forms in this industry are potassium silicate. That's most of the silica products that you see that we've got are going to be potassium silicate. The problem with potassium silicate, it does work, it's effective, but it's not immediately available to the plant. There's some microbial or enzymatic processes that have to happen before the silica is actually available. And so now they make this monosilicic acid that is immediately available to the plant. So you'll see a lot thicker stems, bigger, thicker leaves when you use monosilicic acid. Power SI is the big one. We can't get it in Kentucky, unfortunately, so we use the Kimboy's Silicon Shield. Some other additives, I'm not going to go through all of them because there are a million different things. Amino acids. Amino acids are proteins that plants actually make. All protein, you think of protein coming from animals, but animals get their protein from plants. So plants make proteins in the form of amino acids, but they can also take up amino acids. This is King Cola from Emerald Harvest. A lot of companies are using a soy protein for their amino acid. King Cola actually uses a hemp seed protein, which is pretty cool. I don't know if it's any better, but it's kind of neat. With amino acids, my bodybuilder equivalent there is whey protein. Your body you get protein from your food, but if you supplement with other forms of protein, it's going to be even better. Carbohydrates or sugars. A lot of people think that this is going to make your plant taste sweeter by adding sugars to it. That's not actually how it works. Plants make sugar. They don't eat sugar. The sugars are for the microbes. So especially towards the end of a plant's life cycle, they get a little bit stingy with those sugars that they feed to the microbes. So you can supplement with a product like Bud Candy from Advanced Nutrients, and it's a rich source of sugars that's going to attract more microbes. It's going to build those microbe populations, especially towards the end of the plant's life. PK boosters, which is phosphorus and potassium. Beastie Bloom from Fox Farm. During fruit and flowering, plants use a lot more phosphorus and potassium, so PK boosters are something a lot of people use in mid-flower to boost that up. And then here's another one not a whole lot of people know about is chitosan. I wrote an article for Maximum Yield, I think, on chitosan a couple years ago. Chitosan is actually ground up crustacean shells is what they source it from. It's a byproduct from the seafood industry, and it simulates an insect infestation on your plant. So crustaceans, they're exoskeletons made up of the same kind of stuff that insects are. So when plants sense a high concentration of chitosan, they think they're being attacked by insects, and so it creates an immune response. So the plant beefs up all its immunity. This is also one of those things when people ask, how do you increase potency? How do you increase potency? The real answer is genetics. The potency of the plant is mostly going to come down to genetics, and then, of course, just general plant care. There's no real magic wand to increase potency, but chitosan is one of the only products that specifically will increase potency because that is part of the plant's immune response. When it senses that insect infestation that isn't really there, it's going to increase those essential oils to try to combat the insects. All right. Nutrient questions? Yeah, so terpenes are going to be something else that is that system that is making the essential oils, the medicinal compounds, terpenes. That's all part of the same system. Protects against UV, also protects against insects. So yeah, chitosan is going to do that. Uh huh. Yeah, that covers that. So the no, so potassium silicate gets turned into monosilicic acid in the soil or in the hydroponic solution. So yeah, if you use monosilicic acid, you kind of bypass that whole process. Back one more thing about chitosan. One of the great things about it, a lot of these you really need to read the label, whether it's whether you can use it as a soil drench or foliar feed. With chitosan, you can use it as either. It's available extremely fast. You can actually there's so many things. If you look up chitosan or chitin, which is chitin is actually the compound that they extract chitosan from. It's got a million uses. They're using it for battlefield bandages that bond instantly and protect the wound. Ridiculous amount of uses for chitosan. So they're just finding out. I use it all the time. I use it on my outdoor garden. So I think I'm thinking it's like 10 milliliters per gallon. So you would just mix that into your solution, water it in. So I use it. It's in this. There's some that are more expensive, but High Shield is a product that came out recently that is pretty cost effective. It's a byproduct of the seafood industry, so there's really no reason that it should be that expensive. But everybody's trying to make a buck. But I use it in a foliar spray in my garden all year long. It beefs up the immune response, so it's going to help against insects and fungi and all that bad stuff. And it helps if you're using it with micronutrients. Chitosan and kelp is a great combination. Kelp's got all those micronutrients, plant hormones. Chitosan increases the uptake somehow. I don't even know if they're completely sure how that works, but if you mix chitosan with your micronutrients and apply it in a foliar form, those micronutrients actually get into the plant and circulate through the plant faster. You can combine it with bacteria, and that increases the immune response also. But yeah, chitosan is a big one to look into because it's fascinating. Grow media, obviously, if you don't have a good grow media, then all those expensive nutrients you bought aren't going to do much good for you. You good on battery? So we've got peat moss or sphagnum, clay pebbles, perlite, rock wool, coconut coir. Peat moss, it's ancient moss from big peat bogs, mostly in Canada, that they dig up. And it's actually not a renewable resource, but there's a ridiculous amount of it available. So if you're using like Fox Farm soils, like the Ocean Forest or Happy Frog, most of the soils that you'll see in this industry are going to be based on peat moss and perlite. Clay pebbles, that's what you see in a lot of hydroponic systems, especially people starting their little home lettuce gardens, that kind of thing. They really like clay pebbles. Rock wool that's your greenhouse standard. We'll get into a little bit more of why. And then coconut coir. I really like coconut coir a lot. A lot of the newer soils you see are coconut coir and perlite. Coconut coir is a byproduct of coconut industry. It's essentially ground up husks that simulate soil. So one of the important factors in a hydroponic substrate and what makes them different is something called cation exchange capacity. Cation is a positively charged ion that latches onto the root zone. It's essentially just another way of talking about those minerals that we were talking about earlier. So a low cation exchange capacity means that the substrate isn't going to hold a lot of that nutrient. So rock wool, for instance, has about a 0 cation exchange capacity. That's one reason it's really popular in greenhouse uses, especially in Europe. It will all the nutrients and water that you put into rock wool is completely available to the plant. The plant can suck up just about every bit of everything in that rock wool until it's completely dry. That also means you don't have to rinse out any of those salts, any of those nutrients. Whatever you put into it, the plant's going to be able to take up. and then the next time you water in, you're not going to be mixing it with whatever else is still stuck in the rock wool because nothing's going to be stuck in it. The other thing to consider about rock wool is it does have a high pH starting out, so some people will pre-treat their rock wool to try to bring that pH down. Perlite is just a little bit higher cation exchange capacity, but essentially still nothing. Most people don't use perlite as a medium on its own. I've seen a few people do it, but perlite dries out super, super fast. So if you're going to be using perlite as your hydroponic medium, you better make sure you have a really well automated watering system. Otherwise, if you skip a day of watering, your plant's going to die really, really fast. That's part of the reason that you see perlite in soil recipes is because it increases the aeration, the drainage in soil. That's most of the time what you'll see perlite. Expanded clay, or sometimes called leca. It's got a cation exchange capacity of about 18 to 32, so it's kind of medium. Some people think that it doesn't hold on to any nutrients, but it actually does. Holds on to some water also, so not too much of a buffer if your system dries out, but still more of a buffer than perlite. And then coconut coir, again, the ground up coconut shells is 30 to 40, so a little higher still. Doesn't hold on to a ton of nutrients, but holds on to a little bit, so you've got a buffer. And then peat moss is pretty high, 100 to 120, and it has a low pH. So you're going to want to accompany that in an outdoor garden. People will add lime, but really in indoor, your nutrient salts are typically going to be a little bit higher pH, so it kind of balances out. And the key really with all these, why I'm bringing this up at all, is it determines how your system's going to work. So if you're on this end with the rock wool and perlite, it's a lot faster delivery of the nutrients, but then it's also a faster depletion of the nutrients. So you get really high performance, but there's not much of a buffer there, especially if you're a new grower or if you've got a system that's prone to clogs or anything like that. You probably want to stay away from these a little bit. A lot of new growers will steer them towards peat moss because there's such a big buffer. If you miss a day of watering or you're not giving it the exact right pH or the right amount of nutrients or anything, the peat moss and the cocoa coir to some degree is going to work as a buffer for that. So your plants aren't going to get super dried out. I'm going to go over a few of the different types of hydroponic systems. Flood and drain is the first one that I ever used. It's really, really common. The way this works, you've got your plants sitting in a tray. Usually they're not really connected into anything. They're just kind of sitting in either rock wool blocks or little net cups with the clay pebbles. And you've got a reservoir that is below that. And you've got a pump here that's connected. There's usually going to be a timer. When the pump kicks on, it's going to pump the nutrient solution. So this is water with the solution already mixed into it. When the pump kicks on, it pumps it up here, fills up the tray, soaking all the plants, and then there's this overflow pipe that sends the excess solution back down. So it's gravity. The really nice thing about this system is it's hard for anything to really go wrong. You've got such a big tube here coming from the pump that's never going to clog. You got the overflow, so even if something breaks on your timer and it's just a constant flow, still not ideal, but you're never going to end up with a flood because it's all gravity fed. And then, if your timer just goes out completely, your plants will dry out, but still nothing's going to go wrong. You're not going to get a flood. So that's a very simple system, easy to set up, highly scalable. And what I mean by that is you've got a big tray that gets flooded every few hours, or depending on the size of your plants, every few minutes. And you can just sit your plants in there wherever you want. You don't have to connect them to any kind of tubes or drip stakes or anything like that. So very scalable. You can have just a few plants in there. You can have a ton of plants in there. A couple of downsides, it's recirculating only. And what I mean by recirculating is you're going to use that same nutrient solution. It's going to be pumped over and over and over again. So over time, the pH is going to shift. It's going to get depleted from certain elements that are in there. But you're also saving water because you're not draining that out to waste each time. It's actually getting reused. So sort of upside and downside with that. I say it's less efficient because you got to have a full reservoir to make this work. You're pumping a lot of solution up into this top tray. So to really make the whole system work, you're using a lot of nutrient solution. Even though it's getting recirculated, you got to start with a lot. Typically, you're going to change out that reservoir about once a week to every 2 weeks. Drip irrigation, that's probably the most common that I see these days, especially similar to the flood and drain style, except instead of flooding the tray, the water, or the nutrient solution rather, gets pumped up through this line, pressurizes this line, and it goes in either drip stakes or manifolds. They make all kinds of cool stuff now. A company called Floraflex makes all kinds of different caps and different drippers and drip emitters. And it's very targeted. You don't have to have nearly as much water in your reservoir for that. And I like the top feed because you're pushing those salts down. So any nutrients that were locked up in that clay or rock wool or whatever it is, they're going to get pushed down. And you can run that as recirculating. Here, this is showing a recirculating system. So once the solution goes through the plants, it drains back down. You can actually have this drain just go to waste too. If you dial that in just right, so you're only feeding it the right amount that the plants use, there's really not going to be a lot of waste. So the drain to waste can be kind of deceiving because So that's a really good question. So in the beginning, it depends on how big the plant is and how much substrate you've got. So in the beginning, you're probably only going to water it once a day. But if you're in a really small container and you've got a really big plant, it might have to get watered every few minutes. There are some systems where it's just on all the time. Yeah, just a slow drip, and it's just constant, keeping that medium moist. Easy to set up, just like the flood and drain. Can be recirculated or drained to wastes. It's very efficient because you don't have to have nearly as much solution in the reservoir because you're not flooding an entire tray. You're just feeding the plants what they need. The one huge downside to this is that it's prone to clogs. That's a reason that you do see it in a lot of commercial settings where you've got a full-time staff that can go around and check each plant, make sure it's not clogging up. There are some products they make that you can put in the water, and enzymes and stuff that'll help keep it from clogging a little bit, but at the end of the day, you're always going to eventually run into some kind of clog. Deep water culture, that's a really popular one. We've got a lot of customers doing that, and that's essentially, if you've heard of crack key method, that's kind of the poor man's deep water culture. They're not even using an air stone or anything. They've just got plant roots suspended in water. And that's really what this system is. Usually you're going to have an air stone or some kind of recirculating setup, but really the plants are in some kind of really minimal substrate. Usually it's going to be clay pebbles, and the roots dangle down into the solution. Actually, at first you don't even need any solution touching the plants. The roots will sense that water, and they'll send out these long seeker roots to find where that nutrient solution is, and then they'll go into the water and branch out. Fastest vegetative growth rates I've ever seen. So people who are really limited on plant count, a lot of times like deep water culture because they can put the plants in this system and get them really big, really fast. It's not going to help you that much in flowering. Your growth rates at that point are kind of set by the genetics of the plant. So it'll cut out a lot of time in vegetative, but it's not really going to save you that much time in bloom. Uses way lower concentration of nutrient solution. So something we didn't really get around to talking about today is the concentration of nutrients in the solution. You're going to use an EC meter, which measures the electrical conductivity of the solution. That's going to tell you how much of those ionic compounds are in there. So with a drip system or a flood and drain for peak flowering, you might be running 1,200, 1,500 parts per million in that system. With a system like this, I've seen full flowering plants running at 500 or 600 parts per million, so way, way lower. The whole aspect of it being very fast also is a downside, though. It's way more sensitive to pH and oxygen changes. If you have a pH spike or your air stone goes out, you can have some problems really fast, some root rot or just poor performance. So that's a system that you also kind of like where you have to watch for clogs in the drip system. You're not going to get clogs in a deep water culture, but you're going to get those pH swings, and those the oxygen levels might drop, and your plants are going to die really, really fast. Usually not scalable. A lot of the deep water culture systems, you're going to buy the system that is dedicated to the number of plants that you're going to have. So again, people who are really limited on plant count, or they're sticking to a very specific number of plants, use deep water culture. A lot of hobbyists use this, but it's starting to kind of be phased out of the commercial scale. Still there a little bit, but one of the kind of the big issues with it is it takes a lot of water. A large-scale deep water culture system. We had a 4-plant deep water culture system at the old store. I think it took 60 gallons of water every just to fill the system, and then you're changing that out every week. So for 4 plants, it's kind of a ridiculous amount of water. So people are getting away from that. You don't want to overuse water. All right, last topic, and potentially almost most important. I would say lighting is still most important, but if you've got bad environmental control, you're going to kill your plants just the same, or have really, really poor performance. Well, go back here. So this is fan and filter setup, carbon filter to kill those bad smells, portable air conditioner, and dehumidifier. You're going to want, in a large enough setup, you're going to want all these things. A couple things I want to go over before we get into the rest of it. This is a question that we answer all the time, and that people sometimes have a hard time wrapping their head around, and that's the idea of airflow, and especially in a grow tent, how you want to do your airflow and CO2 air conditioning, that kind of thing. This is an open system, and what I mean by open system is you're bringing in fresh air, and then you're pushing that fresh air out. And that's a big key. We got so many people that they got a fan that's blowing air into the room, or they got a fan that's blowing air out of the room without the other. And it's kind of like your return vents in your house. You gotta, if you're pushing air out of a tent or out of a room, you gotta have somewhere for air to come in. Otherwise, you're just gonna have negative pressure. It's gonna be pulling in through the zippers, and then eventually it's gonna kill your fan. So with an open system, you got fresh air coming in. You're blowing that air out. That's gonna remove the heat. It's also gonna pull CO2 through. You're still going to want a circulating fan. Any kind of grow room, you're going to want a lot of circulation. That's how plants move nutrients and water through their system, is by transpiration. So you've got to move air around so that the moisture can move. It'll moves moisture through the plant, and then also protects against harmful pathogens. But the key here, if you're running an open system like this, which most people in a grow tent are running an open system, you don't want to supplement with CO2, and you're probably not going to want to use AC in that tent. And the reason is, if you're running, you say you've got CO2 bottles or a CO2 generator, you're just going to be losing that CO2. The CO2, it's not intelligent. It doesn't stay in the tent with the plants. It's going to get flushed out with the rest of the air. The good news is ambient CO2 levels in the air are usually around 300 or 400 parts per million. So just running fresh air through the tent is going to be plenty to refresh the CO2 levels. You're not going to get the benefits of a really dialed-in boosted CO2 system, but your plants are going to be just fine with that. And then same thing with air conditioners, dehumidifiers, humidifiers. If you're running fresh air through the system, then that air conditioned air is just going to be getting blown out. Yeah. You can. You don't. It is. It definitely is, because there's all kinds of bad stuff that can come in from outside, bugs and spores and all kinds of stuff. But really, you don't need a carbon filter on that end. You can just use a HEPA filter. And they've got that, and they've got specialized HEPA filters that will fit onto an inline fan like this. So in this is kind of, I'm simulating a small tent here. But really, in a larger room, especially commercial scale, you're not going to be able to get away with just a passive air input. You're going to want a fan here, too. So you're going to want to match the power of your fan here and here. So you got equal pressure, yeah. In a grow tent, you can get away with just one fan with a carbon filter, and then just passive coming in. And they make some little what they call like bug shields. That is just a mesh that goes over the input to keep just bugs and particulate and stuff from coming through. Closed system is there's no air coming in or out of the room at all. You're going to have to supplement with CO2 with that, because otherwise the plants are going to use up all the CO2 in that space, and they're going to be unhealthy real fast. And then air conditioning. In a larger setup, you're definitely going to have air conditioning. The reason I've got a dashed line, if you've got a grow tent in a basement and you're using LEDs especially, you might be able to get away with no AC. You'll just run your carbon filter, just scrubbing mode, just kind of circulating the air in the room, and then of course you're still going to have a circulation fan. So try to really get that across to people. You're either running an open system or a closed system. There's not much in between. Back when people were running air-cooled lights, you could have a closed system where you're pushing air just through the lights and it wasn't mixing with the room air, but people really aren't doing air-cooled lights anymore. I never see that. So yeah, closed system is ideal because you can boost those CO2 levels to 1,000, 1,500 parts per million, and you're going to get a lot better performance out of your plants. So even for a small system, about $1,000 usually. So some people just buy a CO2 tank and a regulator, and they'll put that on a timer to kick it on and off, but you're just flying blind. You want the meter. You want to know where your CO2 level is at, not just guess. Once you've got it, yeah, we sell CO2 bottles, just regular like CO2 gas, like you use on a beer line or something. In a larger facility, you're either going to use a CO2 generator, which just burns natural gas. The downside of that is it does heat up your room, so you're going to have to be pumping more AC. Yeah, there's a little moisture. So yeah, you burn natural gas or propane, and the byproducts of that are CO2 and water. So yeah, it's going to, but the increased AC is generally going to take care of that, because air conditioners serve somewhat as dehumidifiers too. So yeah, that's an issue with the burner. On a really large scale, people will do the liquid CO2. So they'll have a huge dewar of liquid CO2 on the outside of their building, and then every couple of weeks they have a truck that pulls up and just refills that liquid dewar. So that's probably the most cost-effective way, and then you're not dealing with the extra heat and the moisture. Well, a lot of people will have they'll have their no, go back here. So say this is blowing into your bedroom and that's pulling in from the bedroom. So it's closed, but it's exchanging air between two rooms. I've seen a lot of people who do that. So they've got their entire facility is on one CO2 generator, and it's just keeping that all at the same level. Um, yeah. I mean, you could run it lower in veg, but I think really veg is where you get a lot of the benefits of CO2, because you get a lot faster vegetative growth. So yeah, 1,000 to 1,500 is where people typically run it. And yeah, I've seen a lot of people that just run their whole facility at that same level. Some people say yes, some people say no. So some people say plants can handle they can handle higher temperatures better if they're running more CO2. I think what it really comes down to is you should be running higher temperatures in your garden. We'll get to that in a couple slides, but a lot of people were used to running high pressure sodium, and you had to run AC a lot to keep your plants cool because 72 is that 72, 73. Everybody always says that because with HID lights, they're just pounding your plants with infrared. So they're just baking your plants. So you run AC really cold to try to make up for that. Now people are running LEDs. I think that's a big reason that even using a good LED, a lot of HPS growers don't get the same performance because they're used to running their rooms cold. But your plants are going to perform better when they're warm. You look at the rainforest, and it's so much growth in a rainforest that it stinks of rotten plants because they're just growing and falling over and rotting constantly. And part of that is that higher heat. A plant is a big chemical factory. Chemical reactions are aided by heat. it speeds up those reactions. So up to a certain point, beyond a certain temperature, the plant's going to suffer. But a warmer plant is going to do those chemical reactions faster, and the main chemical reaction that a plant does is fixing CO2. So warmer conditions, the plant's going to be metabolizing faster, and it's going to be taking up more CO2 because of that. So yeah, I would say, short answer is there is a relation, but I think the old idea of your plants can take more heat stress with CO2, I'm not sure if that's really true or not. But yeah, there's definitely something to that. But CO2 is great. If you can run CO2, if you're running, I prefer to run a closed system with air conditioners, dehumidifiers, humidifiers, CO2, and have everything just dialed to exactly where you want it. That's when you're going to get the best performance. So ideal temperature is what we were just talking about. I stole this little infographic from Gavita, and this is kind of what I was talking about with the difference between LED and HPS in terms of the transpiration. So LED, there's almost no infrared in the LED spectrum, and so they're not the heat that comes from an LED. You can see these little squiggly lines is usually going up. It's coming up off the driver, off the back of the diodes, and that's really nice for a grow room because your circulating fans and your air conditioner can take care of that heat really easily when it's coming off the back. With an HPS or really any kind of HID, most of the heat that it produces is actually not from the driver. You see a little bit there, but most of the heat that an HPS produces is in the form of infrared light. So it is shooting that light at your plants, and there's no amount of, you can blow a fan straight at that bulb, and it's not going to kill that infrared heat because it's actually in the light, and it becomes heat when it hits the surface. So because of that, we got it here. So yeah, LED, if you're looking at just the room temperature, ambient room temperature, ideal for an LED grow is about 82 degrees, which is warmer than a lot of people are used to. But I've seen so many people who said, I'm not getting yields with LED, I'm not getting the yields. And you tell them, bump that temperature up, bump it up to 82. And it's a scary thing when you're used to growing with HPS, because if your room temperature is 82 with HPS, your plants are going to be fried. And the reason is because the leaf temperature is a lot higher than that because of that infrared energy that's hitting the leaf surface. So ideal room temp, like we were talking about, 72 degrees for HPS room. This whole factor also influences transpiration. So in an LED system, your plants aren't going to use as much water. So you're typically going to have to run your nutrient solution a little bit more concentrated. In the beginning, people thought that was because LEDs drove your plants harder. That might be some truth to that, but really it's because they're not transpiring as much water. So you've got to have a higher concentration of those minerals in the nutrient solution so the plant is getting, they're not taking up as much of that solution. You got to have a higher concentration so that they still get all the food they need. HPS, it's going to have a ton of transpiration, so you're going to have to run more dehumidification, more AC, because there's more heat, and then also a lower nutrient concentration in the solution. Really, the key to all this, and I don't worry about room temperature so much as I worry about leaf surface temperature. You can use one of these little infrared thermometers that we sell in the store. That's really the way to do it, is take measurements of different parts of your room, different parts of the plant, and make sure that your leaf surface temperature is dialed in somewhere between about 78 and 84. I even know people who go higher than that, 85, 86. But really, typically that's the sweet spot. And the reason is, I'm not going to get too much into this because this is way too in-depth information, but the reason that temperature and humidity matter, the Kelvin cycle, this is the nitty-gritty of that CO2 respiration, and how the ATP gets recirculated in the plant, and warmer temperatures in that particular range are going to make this cycle happen more efficiently. The reason humidity really matters is having the ideal humidity is going to determine stomatal dilation. So the stomata, the little holes in the bottom of your leaves, and that's where plants release the water for transpiration. It's also where they bring in CO2. And like we talked before, CO2 is that's the most important thing to a plant. That's, it's turning those. What's that? So, when people ask me that, I usually say 40 to 60%, but that's kind of a cop out answer, because it actually depends on the heat. And the reason that is, when you have a situation with high heat and low humidity, the plant's going to be transpiring too much water. Those, the conditions are right. High heat, low humidity. It's like, evaporate really fast, and so the plant's going to be going through a ton of water. And the way that it stops that, the plant doesn't know that it's in a hydroponic system and it has unlimited amounts of water. The plant is evolved to try to stop that fast transpiration. So what it'll do is it'll constrict the stomata, to try to help prevent it from losing water. The downside of that is when it constricts the stomata, it can't take in nearly as much CO2. So having the right ratio of humidity and heat it's going to give you the fastest growth rates, because you'll be able to keep those stomata dilated in their most open form, so that they're able to take in as much CO2 as possible. Well, actually, this is my final slide. And my voice is going out, so I'm glad this is my final slide. But VPD, vapor pressure deficit, it's a huge hot word right now if you go on grow forums. Everybody's talking about VPD. Most of them don't really know what they're talking about. VPD is just a ratio of temperature and humidity. This is a VPD chart from Pulse Labs. And VPD charts, they make different ones for different plants. A lot of people, say, oh, I live and die by VPD. If you live and die by VPD, you're probably just going to die, or more specifically, your plants are going to die, because you can be in this green zone and have some really horrible conditions. So 113 degrees, and what is that? 80% humidity. So this VPD chart is going to tell you that's good, because it's an ideal ratio of temperature and humidity. But if you've got a 113 degree grow room with 80% humidity, your plant's going to be really sad. You're going to be setting up conditions for all kinds of pathogens to take over. So you got to be sensible about it. But the true answer of what should my humidity be, it's going to be relative to the temperature, again, because of that stomatal dilation. So if I'm telling you about 82, 84 degrees Fahrenheit for your LED grow room, that's going to put your humidity, about 60%, somewhere in there. So like you said, you're going to want it. A lot of people run their humidity a little bit too low, just because it does help prevent some pathogens. It's a little bit of a double-edged sword, because low humidity conditions, spores are more viable. Spores can travel. Right. They're light and they don't stick to the surfaces as much, so they can travel through the air. But then high humidity situations, the mold grows faster. So there's a balance there. But yeah, I normally tell people 40 to 60, because it's a safe range as far as the mold. Yeah. Right. Nothing's going to die because of the humidity, and you're in a safe range as far as mold goes. But I've seen people in commercial grows that fog with peroxide every day, so they're not really worried about fungal stuff quite as bad. But I've seen them really push it, up to 90 degrees and like 70% humidity, or even beyond that. So the plants, and like I said, in a rainforest, it's high heat, high humidity, and those are nearly ideal growing conditions. So VPD is definitely something to check out and to keep an eye on. But again, I would say not to live or die by the VPD chart. Be sensible. I think that's all I got for you. Yeah. Thanks for coming out.